Okay, so in this example of integration by parts, I've got x squared multiplied by e to the x. Now, I'm going to pick u here. Again, I'm looking to make my life easier, so I'm going to pick u to be x squared. I'm going to put on this video, again, a little star by the ones I'm picking. Okay, I won't do that much longer, but it helps to see it the first day at least. So that means if u is x squared, if this is u, then the rest is dv. So now I fill in the rest. And we do the magic 7. Okay. So I've got uv minus the integral of v du. Okay. Now, in the previous video, we did an example of x cosine x where at this point it just worked out. It was perfect. We just said, okay, the antiderivative is easy to see. It's not as easy to see here. Okay, this term certainly looks okay right here. I'm going to put this is okay, and that's set. But this term is still a product, so we need to do integration by parts again. Okay. Now, the reason I know we have to do it again, and it's not getting more complicated. I mean, it's not getting more complicated. It started off as a parabola multiplied by e to the x. Now it's linear. And if I think about picking u again as 2x, then the du will just be 2. So it's getting down now to just be a constant. Well, that's better, right, if we can work our way down. One way to pick your u is to look for the thing that what we say will terminate, meaning if I found the derivative enough times, I would end up with simply 0. It would terminate out. And in this case, like the derivative of x squared is 2x, the derivative of 2x is 2, the derivative of 2 is 0. So at some point, that will terminate. That's not a bad way, at least at the beginning, to try and pick your u. Of course, you might run into problems if nothing terminates. Maybe maybe your product was e to the x cosine x, but that we'll save for a little more advanced integration by parts video later. Okay. So magic 7 again, we've got uv minus the integral of v du. Okay. I'm going to kind of put this in brackets because remember we had this okay term out front that was fine. It was x squared e to the x minus this whole thing. Well, here we pull the 2 out front, and now it's just the antiderivative of e to the x, which is e to the x. So that's easy enough. It's just 2e to the x right there. So let's finish this off. Our first term is x squared e to the x. Then we have minus 2x e to the x. And then we had minus a negative, so that becomes plus 2e to the x plus c. Here is our integral. Okay. Now, I want to show you the method that was featured in the movie Stand and Deliver. He referred to it as Tic-Tac-Toe method. And I'll show it to you and why it gets us to the same spot. So kind of keep this in your memory that's the answer. Let me show that to you on the next slide. Okay. So it's the same problem. I'll do it with a different problem in a minute. And we start the same way. We still have to pick u and dv. And I would still pick it the same way. Look, at least to begin with, for something that terminates. Okay. And then, of course, we have u, so we need du. So we do the derivative. And just keep going. The derivative of 2x is 2. The derivative of 2 is 0. All right, well, everything else was dv, so e to the x. And, of course, the antiderivatives, if we had dv, we want v. The antiderivatives are always just e to the x. Our very first term, according to the formula, is uv. So uv. Then we just draw diagonals from there. The first term is positive uv. And then we subtract, and the signs just alternate. So the very first term is x squared, positive x squared e to the x. The next term is negative 2x e to the x. And the next term is positive 2e to the x. We put a plus c. And then we and it is the same thing we got on the previous slide. Some things to be careful with this tic-tac-toe method. I am going to show you one more example, but some things to be careful with, things that don't terminate. You know, if our integral was e to the x multiplied by cosine x, this isn't going to work. If our integral was something with natural log, it's tempting when you see something like, if I could write it down here, if you saw something like x squared natural log of x, it's tempting to say, well, I want u to be x squared, and then dv is natural log x. The problem is you don't know the antiderivative of natural log x. So that can't be your dv. So every time you see a natural log, this has to be u. And then you can't use in a tic-tac-toe method. Okay, I would just never use it because natural log actually makes things very, very quick and easy. If you do tic-tac-toe method, you might miss it. So I would never use tic-tac-toe method for a natural log. So things to kind of, you know, because tic-tac-toe method works great, but some things to kind of say, no, I can't use it is, what if both functions are non-terminating, like a trig function multiplied by an exponential function? Or what if one of the functions is natural log? Those are cases where I would continue to use the magic 7, okay, actually using the formula. Let's do one more problem where the tic-tac-toe does work, though. Of course, this is a great example because x to the 4th cosine x. If you think about this thing having to terminate, you'd actually have to do integration by parts 4 times. So it's obviously a great example of when tic-tac-toe method is useful. U is the one that'll terminate. So then we just do the derivatives. Until it does terminate. The other function is our dv. And we do antiderivatives. That. First term is u times v, so it's diagonal. We just do the diagonals after that. First term's positive, and then it just alternates. So our first term is x to the 4th multiplied by sine x, and it's positive. Our next term is minus, but it's 4x cubed times negative cosine, so minus a negative is positive. Then we have a positive, but it's 12x squared multiplied by negative sine, so positive times negative is negative. And then we've got negative 24x cosine x. We got 24 sine x, plus c. And there's our integral. So again, it works really, really slick. A really nice way to do some pretty complex integration by parts problems. And it works best when you've got something that'll terminate multiplied by something that won't, that's not natural log. So if I can just kind of reiterate this, the formula is worth memorizing. Okay, this formula right here, if you do it with the magic 7 or something, that's fine, but I would absolutely memorize that formula and memorize how to do the magic 7. The reason I say that is because more often than not, on an AP exam, you won't be given one that is as easy as tic-tac-toe method. Now, that's not always. It has happened before where you've gotten one where tic-tac-toe method will work. But more often than that, you actually get something where you need to use the formula. And there are cases to using the formula. As I said, if it's non-terminating, if both functions don't terminate, logarithmic functions, exponential, I'm sorry, not logarithmic, natural log is a case you wouldn't, but exponential, trigonometric are the two most common non-terminating ones you'll see. But natural log is another case where I would never use tic-tac-toe method because natural log actually will cancel things out for you really, really fast. I'll show that in a later video. And you don't see that if you do tic-tac-toe method. So tic-tac-toe method is really reserved for times where you've got a polynomial where you can just use power rule multiplied by something like e to the x or a trig function. Okay? So just be careful with that. Make sure you know really both methods of integration by parts.